This lesson is the third that pertains to solving systems of linear equations. We looked first at solving by graphing. Then next we looked at the substitution method for solving. This is the third method, which is also a mathematical method, and it is called the elimination method. It's also referred to as the addition method. So in the textbook or in the homework, it may be referred to in either way. The procedure to solve a system of equations by the elimination method is to set the two equations such that all the x's and y's are on the left side, the constant terms on the right hand side. So you want to line the x terms up in a column, you want to line the y terms up in a column, the equal sign under one another, and then on the right side the two constants line up in a column. Next, you look at your variables and decide which one it would be easiest to make cancel out by multiplying it by a certain number. So in other words, decide whether you want to eliminate x or you want to eliminate y. Then you're going to pick two numbers to multiply the two equations by. You'll multiply the top equation by one number, you'll multiply the bottom equation by a different number. Those numbers should result in the coefficients in front of that variable you decided to eliminate cancel out when you add them together. This will be a little clearer when we look at an example. Once you have done the multiplication, add the two equations together, which means add your columns. When you do that, the variable you chose will cancel and you'll have only the other variable remaining. Solve that resulting equation and you'll get a value for that variable. Take the value for that variable, substitute it back into one of the original equations, and solve that equation to get a value for the other variable. You can check both of them by substituting both into the original equation. Here's an example. Here we have two linear equations. Both of them have x, both of them have y. They have already been set up with the x's lined up in one column, the y's lined up in another column, then the equal sign, then the constants lined up in a column on the right hand side. That's the way you need to have these equations in order to apply this method. Next, we're going to choose one of the variables that we want to eliminate. And it is completely up to you. There is no requirement that you choose a particular variable. Pick one. I would pick one that you think would be the easiest to eliminate. By eliminate, what I mean, we want to take one of the variables and we want to multiply the number in front of it in both equations such that one of them will become plus a number, the other one minus a number. We could do it with the y's also. We could do it with either one. We can't do both at the same time usually, but we can do one or the other. In this example, I have decided to eliminate the x variable, which means I need to get the number in front of the x in this equation to be minus the number that's in front of the x in this equation. One of them has to be plus, one of them must be minus. They both must have the same numeric value. I can do that by multiplying the first equation by plus 1 and multiplying the second equation by minus 3. Because when I multiply plus 1 times plus 3, that's going to give me plus 3. When I multiply minus 3 times plus 1, that's going to give me minus 3. Then I'll have plus 3 here and minus 3 here. When I perform the multiplications, I must remember to multiply times every term in the equation. In that one and also in this one. In the top equation, when I do that, 1 times 3x gives me 3x, 1 times y gives me y, 1 times 8 gives me 8. in the bottom equation, minus 3 times x gives me minus 3x. Minus 3 times plus 5 gives me minus 15y. Minus 3 times minus 2 gives me plus 6. Now I have new versions of my two equations. These are my new versions of these original two equations. This is what they originally looked like. Now they look like this. Because I did the same thing to both sides, they're still the same equation, just written in a different way. But notice that these two things here, these numbers in front of the x, one of them is plus 3, the other is minus 3. That's what I must get to for this method to work. Now I add these two versions of the equation together. So I'm going to add this column up, and I'm also going to add this column up, and I'm going to add this column. So when I do that, 3x minus 3x gives me 0. Plus 1y minus 15y gives me minus 14y. 8 plus 6 gives me 14. Solving that last equation for y, which means divide both sides by minus 14, gives me y equals minus 1. I have a value for y from my two equations. Take this value for y, this minus 1, and I want to put it back into one of the two equations. So I'm going to pick the top equation, and I'm going to put minus 1 in for y. So I'm going to put minus 1 in right there. When I do that, then I get an equation that only has x in it. So solve that equation for x. Add 1 to both sides, divide both sides by 3. I get x equals 3. Now I have a value for x and I have a value for y. Thus the solution is 3 comma minus 1. This is one of those situations where you get a single point as the solution to the system. This would be the same as if the graphs crossed. That's the technique. Here's another example. We want to use the elimination method. The variables are already lined up in columns. We don't need to rearrange it all because I have the x's together, the y's together, and the constants together. But if I want to eliminate this, I need to get rid of or use the elimination method, I need to choose one of the variables. I'm going to eliminate x again. In order to do that, I need to make these two numbers, one of them be plus and one of them be minus. Well, that one's plus and that one's minus. So if I just multiply this by 2, then this will be plus 6 and this will be minus 6. So let's do that. Multiply the first equation by plus 2. 2 times 3x gives 6x, 2 times minus 2y gives minus 4y, 2 times 1 gives 2. The second equation, I don't need to multiply by anything. It already has the right value and the right sign, or you can think about it as multiplying this equation by plus 1. It really is not going to change anything because I already have the minus 6 that I want to go with this plus 6. So I just write it down below. So here are my two equations now. First equation and second equation. First equation has been modified. The second one did not need to be. Now let's add the two equations together. When I add 6x minus 6x, I get 0. When I add minus 4y plus 4y, I get 0. So the left-hand side is 0. When I add 5 and 2, I get 7. And what happened? My variables canceled. This is one of those two situations. If your variables cancel during the process, then you're either going to have no solution or you're going to have an infinite number of solutions. The way to determine which you have is to look at this equation here. Is that equation true or is that equation false? Obviously, 0 does not equal 7. Therefore, that equation is false. And that means no solution for this system. The process we follow is exactly the same as we did in the previous example that you would do for any system of equations where you're using the elimination method. You're going to line the variables up, choose a variable to get rid of, multiply by the appropriate things, add the equations together. In this case, though, the variables canceled. Both x and y canceled. When that happens, you look at the resulting equation. If it's true, the answer will be an infinite number of values. When the answer is when the equation is false, the answer is no solution. Let's do some practice problems. When you're looking at the two equations, you're free to choose whichever variable you want to get rid of. This set of equations, it doesn't really make a whole lot of difference. I can choose to get rid of the x's, in which case I would need to multiply one of the two equations by -1 and leave the other equation alone. I could also choose to get rid of the y instead. In that case, I would need to leave the -3 alone because it's negative, but I would need to multiply the bottom equation by +3 so that I would have -3 and +3. Either way will work. It will eliminate one of the variables, solve for the other one, get a value. Once you have that value, plug it in to one of these equations and solve for the answer. You should do this as practice. The answer is -1, -2. That is the point that satisfies both equations. You can verify it by plugging those values into each of the equations and see that indeed the equations are true with those values. Second example, if you go through the same process, what's going to happen is your variables are going to cancel one another. But in this case, you're going to wind up with an equation which is true, therefore your answer is an infinite number of solutions. There's one other point to make with this set of equations here. This equation has x and y on the left side and the constant on the right side. This equation does not. Therefore, this second equation here will need to be modified. We would need to move the 8x to the left-hand side. Therefore, we would need to subtract 8x from both sides in order to put it in the proper form where you have a column for x's, a column for y's, the equal sign, and then a column for the constant terms. If you apply the elimination method here, and again this could be a good practice for you to try it on your own, but if you go through the steps, we would need to either eliminate the x or the y, either one's fine. To eliminate the x, I would multiply this equation by -6, so that I have -6 and +6. If I want to eliminate the y, then I would multiply one of the equations by -1. I can multiply this one by -1, or I can multiply that one by -1. It doesn't make any difference. Once you have applied the right multiplication, add the equations, and one of the variables should cancel out. Solve the equation that you get from doing that to get a value for the other variable. Plug that value in to get a second value, and what you should wind up getting is some other answer. I'm going to leave that to you to figure out what that other answer is. A place where system of equations can be useful. When you're setting up word problems, it can be difficult to determine what the equation is when you only have one equation. If you have multiple unknowns, it's usually going to be easier if you have an unknown or a variable for each unknown. So Here, where we're looking for two different things, we're looking for how many students made an A, how many students made a B. That's two different things. I don't know either answer. Pick two variables. In this case, I'm going to call the variables A and the variable B, but those are going to make my two variables. A is the number of students who made an A, B is the number of students who made a B. With two variables, I can then take the existing pieces of information. I want to know how many, that's my question. But you have total of 75 students. The word total means to add something together. What is it you're adding together? You're adding the number of students with an A and the number of students with a B. And you're going to get a sum of 75. So there's one equation that just naturally falls together because you're adding two things and getting 75. The other part here, 5 more students made an A. A is 5 larger than B. So A is going to be B plus 5. Put that together. Total number of students was 75. A plus B equals 75. That's what total means, is to add up. 5 more A's and B's. A equals B plus 5. Now I have two equations with two unknowns. That's a system of equations. Use one of the techniques. In this case, I'm going to use substitution. The reason I'm going to choose substitution is look at the form of this equation. It is already solved for y. I'm sorry, solved for a in this case. It is already solved for one of the variables. It is very simple then to take this right-hand side and substitute it in there. So that's what I do. That gives me an equation that only has b. Solve that equation for b and I get b equals 35. B is part of what I need for an answer. I also need to know B is how many students made a B, so 35 students made a B, but I also need to know how many students made an A. To get that, I can substitute into this equation. I know a value now for this, so I'll put 35 in there and do the calculations, and I get A equals 40. So there were 40 A's and 35 B's. The setup can become easier if you use multiple variables when you have multiple unknowns. This is another one that uses the same thing. I'm not going to go through the details of how. Just follow up the procedure as in the previous example. The answer, the hamburger has 21 grams of fat, the fries 67 grams. These are some more examples for the same sort of applications, which we can work on sometime if you have problems. If we have time in class, we'll do some of those during the review. But try them on your own.